Hi. This video will explain the parametric analysis in Cadence. So before watching this video, I prefer you to watch the DC analysis and the tutorial on DC analysis and transient analysis. So the parametric analysis is used to change a parameter and to repeat the simulation with that change in the parameter. Suppose we have a DC simulation, and if we define a parameter and we'll repeat the same DC simulation for the different values for this parameter. Let's do one example. For example, place a MOSFET here, and I need a voltage source from the analog library. The DC source I gave 3 volt, and I need a ground also. I am connecting the body also to the ground and the drain to the 3 volt. I am naming this node as this voltage source I am naming is V underscore VDS. So it will act as the VDS for this MOSFET, and I need VGS also. So I connected the VGS and selected the VGS to be 1 volt. Okay. If we want, we can rename this as VGS. Press OK. And now let's do a transient analysis. So I want a liberal for 1 micro. I want to plot the output current. I want the drain current of this MOSFET, and run the simulation. So the drain current I am getting is 356 microampere. So the dimension of the MOSFET is 10 micro by 0.35, so I am increasing the length to 2 micro. Okay, 2 micro is not needed. I am make length to 1 micro and the width to 2 micro. I am running the simulation again. Now the current is 27 microampere. So basically we did one transient analysis now, and we found the current through the MOSFET. So we didn't define any parameter. So parametric analysis means we define one parameter and we repeat the same simulation with the different values for that parameter. For example, select the MOSFET. The MOSFET width I am, instead of giving a value, I am defining as a parameter. I am giving P n underscore width. I can give this value as a variable. So the n underscore width become a parameter now, and press OK. Save this. And in the unlocked design environment, in this, here you have the design variables. You right click here and the design variable copy from cell view. I already entered a design variable to the cell view, so now you can press this so that this variable will appear here. So n underscore width is the width of this NMOS. So instead of giving a value, I give a parameter, a variable name, and now I can give 2 micro here and run the simulation. So it will give the exact same result of 27. Now you can do the parametric analysis. Go to the tools and parametric analysis. Here the variable you can add, the variable will appear here. The n underscore width is already here. So I want to see how much the current is varying for a different transistor, different MOSFETs width. So I want to see the width from 1 micro to 10 micro in a total step of 10. If we put a step mode auto, total step numbers we have to specify. So it will run 10 simulations from 1 micro to 10 micro. It will run 10 simulation and it will give the result. So in between 1 micro and 10 micro, it will take 10 points and it will do the transient analysis for all these values and display the result. So just run the simulation. Okay, not that one. Here you have to run here. Select the run selected sweeps. You can see the progress of the simulation. And this is the current for all these MOSFET sizes. So you can see here when width is 1 micro, so this is the highlighted one. So this is the current, that is 13.36 is the current. And if when the width is 2 micro, 27 microampere is the current, and the width is 3 micro, the current is 41 micro. Like that, we have 10 simulation here. So now you can find if the width is 10 micrometer, the current is 141 microampere. So this is one example for the parametric simulation. So we can give any value, anything as the parameter. Here I gave the width as the parameter. If we want, we can give the length also the parameter. So instead of length giving a value, I give len. I gave. Okay, I save the schematic. Here right click, copy from cell view. Here that len will come here. So I placed 1 microampere here, 1 micrometer here, and I can run the simulation, or I can do the same parametric analysis again, but now with instead of the width I can give the length. So I want the length from 0.35 micro to 1 micro, or and a step mode I give again auto, but this time I need only 2 simulations. So let's run the simulation, and you can see for the 2 different length how much is the current. Now suppose I want to change the length from 1 micro to 5 micro. Instead of auto step, I have other options like linear steps, linear, octave, decade, logarithmics and all. So if I select the linear steps, it is asking the step size. So from 1 micro to 5 micro, if I give step size as 1 micro, it will simulate L for 1 micro, 2 micro and up to 5 with a step size 1 micro. So there will be total 5 simulation here. Okay, it gives the current for the different length from 1 micro to 5 micro. So I am now deleting that parameter and putting the 2 micro and 1 micro here, and here I can delete all these parameters by delete. And one typical example for the parametric analysis is the MOSFET IV Cara. For example, if I want to plot the IV Cara of the MOSFET, that ID versus VGS, I have to do the DC sweep. So I am selecting the DC and the component parameter, select component, and I selected the DC value of VGS. I want to sweep. So the VGS I want to sweep from 0 to 3. Okay, the sweep type I am just keeping it automatic. I am deselecting the transient. Now this gives the curve that this is the VGS versus this is the ID versus VGS for the MOSFET. So if you want to repeat the same curve for different value of VDS, then we can do the parametric analysis. So whatever you want to appear in the x-axis, you should give that as the DC sweep. So we give the VGS as the DC sweep here. So one simulation we got one simulation of ID versus VGS. Now I want to repeat the same simulation. I want to repeat the ID versus VGS simulation for different values of VDS. So I have to give VDS as the parameter here. So this VDS DC voltage, instead of 3 volt, I am giving any name I can give as a parameter. I just give VD. Here you have to copy from cell view. So VD appeared here. Now I can give any value here. Just I give 1 volt. So now I want to plot ID versus VGS for different values of VDS. So I can go to tools, parametric analysis. Here VD I want to change from 1 volt to 3 volt. Linear steps of let's say 4. Okay, I need 4 simulation, so I give auto and total steps 4. So now the simulation result will contain a plot versus ID versus VGS. So x-axis will be VGS for different values of VDS. So let's plot that. So this is the curve showing ID versus VGS for different values of VDS. For example, the selected curve, the green one is when the VDS is 1 volt, and this is when VDS is 1.67, and this is when the VDS is 2.33, and this is when the VDS is 3. So this is the curve between ID and VGS. Suppose I need a curve with ID versus VDS for different values of VGS. These are the two common graphs for the MOSFET Cara. ID versus VGS for different values of VDS. The second one is ID versus VDS for different values of VGS. So now we need VDS in the x-axis and ID in the y-axis. For that, if VDS, we want VDS to be appear on the x-axis, we have to give the DC sweep for VDS. So instead of VGS, I select the component and I selected VDS, the DC value of VDS. So this VDS I want to change from 0 to 3. The sweep type I can give linear or something, but I am giving automatic, and just run the simulation. Now this will plot the VD. This is the drain voltage, so VDS versus ID curve. Now I want to repeat this simulation for different values of VGS. For that purpose, I have to give the VGS as a parameter. So instead of giving a voltage, I am giving VGS here as a parameter. Save the schematic, copy from cell view. Now VGS appeared here. You can give any value here. Suppose I give 3, and if you run the curve, it will run the simulation for a VGS 3, VDS also 3. But if you want VDS in the x-axis, if you want ID versus VDS curve for different values of VGS, you have to do the parametric analysis for the VGS. So the parametric analysis, now I want VGS to be varied from 1 volt to 3 volt with linear steps of step size 0.5. Let's run the simulation. So this is a very familiar curve for you. This is the ID versus VGS. So this is also one example for the usefulness of parametric analysis. Now you can so you can define the parameter. You can define anything as the parameter. We did the length of the MOSFET, we gave as parameter. We gave width of the MOSFET as the parameter, or we can give, and we give the voltages also as a parameter, and you can do the temperature also for the parametric analysis. So I added one more variable, add new row, and I added the temperature, and I am deselecting the VGS. So now VGS is not in picture, only the temperature is in picture. So I want the VGS to be something lower value. So the temperature I want to sweep from -40 to 150 degree. Step size, instead of giving step size, I am giving total step of 10. And let's run the simulation. So this will give the ID versus VDS curve for different temperatures. So for different temperature, this will be the ID versus VDS curve. So this temperature, this is for -40, and this is for 150 degree centigrade temperature. If you want, you can give the nested sweep also. If you select both of them, then it will, for each value of VGS, it will run all the temperature sweep. So there will be a lot of simulations here. So I am reducing the step size to 1 volt, and total temperature also I am reducing to 4. So we will first, the simulator will set the VGS to 1 volt and it will do all the temperature variation. Then the VGS will be set to 2 volt and it will do the temperature again. So there will be a totally, you can see, total 11 simulation, total 12 simulation will be there, 3 into 4. So this will give you both the temperature behavior and the change in the ID versus VDS curve with respect to temperature and VGS. So here we added two variables for the parametric analysis. If you wish, you can add any number of variables, it is not a problem. So I am stopping this tutorial here. We discussed the parametric analysis. It is used to repeat a simulation with different parameter, with different values of parameter. You can set any number of parameter you want, and we discussed some example. We discussed some typical example also. I'm stopping here. Thank you for watching.